Hello everyone. In this problem, there is a cubic function f of x, and the leading coefficient is 1, and its inverse is g of x. And h of x has two pieces. When x is not equal to k, the first piece is used. And when x is equal to k, the value is 1/3. And k is positive number. And we want to make f prime of 0 maximum. And h of x should satisfy the two conditions. The first condition is h of 0 is equal to 1. The second condition is h of x is continuous in all real numbers. And when these conditions are met, the value of k is equal to alpha. So we can start with f of x cubed ax squared plus bx plus c. And for the first condition, because k is not 0, h of 0 is g of 0 minus k over 0 minus k. And because that's equal to 1, g of 0 is equal to 0. And that means f of 0 is also equal to 0. And to be continuous, when x approaches k, the limit value should be equal to 1/3. For the limit value to exist, g of k is equal to k, and that means f of k is also equal to k. And by the definition, g prime of k is equal to 1/3. And because f and k are inverses, their derivative is reciprocal. So that means f of prime of k is equal to 3. So let's use these conditions to find f of x. At first, because f of 0 is 0, c is 0. So f of x is x cubed plus ax squared plus bx. And with this condition, k is equal to k cubed plus ak squared plus bk. And if we make the derivative, f prime of x is 3x squared plus 2ax plus b. And if we use this condition, 3 is equal to 3k squared plus 2ak plus b. And for cubic function to have an inverse, its derivative should be greater than or equal to 0. And that means it needs to be always increasing. So this f prime of x should be greater than or equal to 0. For the case, the determinant should be less than or equal to 0. Because k is greater than 0, or we can divide this equation by k. And then let's multiply 2 to both sides. And we are going to subtract this equation. That makes so b is equal to k squared minus 1. And if we switch b with k squared minus 1, this equation becomes this. That means AK is So A is 2 times 1 minus k squared divided by k. And we are going to use discriminant. So A squared is and 4 minus 3b because k squared is positive, we can multiply k squared to both the sides. So for this to be 0, k squared should be between 1 and 4, and because k is positive, k is between 1 and 2 inclusive. And because we want to make f prime 0 positive, f prime 0 is b. So with this interval, this value is maximum when k is 2, and the k value is alpha. And when k is 2, b is 3, and a is minus 3. So f of x is x cubed minus 3x squared plus 3x. So let's find out the value of h of 9. That's equal to g of 9 minus 2 over 9 minus 2. And to find g of 9, f of x is 9. When you solve this equation, x is 3. That means g of 9 is 3. So h of 9 is 1, 7. And to find the value of g prime of 9, if we make the derivative of this equation, we can make this derivative. So g prime of 9 is equal to 1 over f prime of g of 9. And because g of 9 is 3, we can use f prime of 3. So f prime x is 3x squared minus 6x plus 3. And so f prime of 3 is 12. So g prime of 9 is 1/12. So finally, if we multiply all these three values, we get 1 over 42. And so the answer is option 2. So to solve this problem, we used the property of inverse and its derivative. That's it for this video, and thanks for watching.